Okay, good morning. Welcome to the intro session for differential equations online for the summer. Um, so we're going to just kind of quickly review some of the administrative details for the course, go through uh, the Blackboard site, some of the ancillaries and so on, and then answer any questions that you have. So um, the the session is being recorded, so that way, anybody who's not able to make it, I certainly don't expect folks in an online course to, necessarily be able to make it to a live session. But this way, everybody will be able to review the same material. Okay, so you should by now hopefully have logged on to the Blackboard site at either courses.ccac.edu or through the portal. One note, the new Blackboard site kind of looks like this. I don't particularly like this view. I think it's a little less efficient. So I like the old version. So I will pop the kind of direct link to the old version in chat, just in case any of you prefer this look. I think it's a little more efficient particularly because you can kind of control click and open up, different course sections and that kind of thing and have multiple tabs open, where this one doesn't seem to do that as well. And also you can see that current courses is selected, but it has courses from spring of 2022 that are popping up as current courses for me for some reason. So I like the old version better. But courses.ccac.edu, if you haven't been on the Blackboard site and looked around, make sure to do that today to make sure that you're able to access everything that you need to access. I posted an announcement just before our meeting right now for the day 2 assignments, and the week 1 announcement for the day 1 assignments on Monday was posted yesterday. So make sure that you've kind of completed that assignment first and then get to work on today's assignment. A lot of this stuff is just kind of getting up to speed with the course, getting used to the administrative side of things, figuring out where everything is located and so on. We'll come back to homework assignments in just a minute here. I've also posted a discussion board, so you can come on here and kind of introduce yourself to the class. I just made this available today as part of the day 2 goals. So you can come on, with an online course. It can feel a little bit disconnected. It can feel a little bit like you're not really part of a class. And hopefully this will foster a little bit of discussion. You can kind of meet, in a sense, some of your other classmates, and then there will be a couple other discussion boards posted throughout the semester. Again, just to try to make it feel a little more like a normal classroom. We'll also come back to the syllabus. So we'll save the homework and the syllabus for a little bit later. The textbook information, I wanted to address this kind of right off the top. The textbook for the course is Nagel's Differential Equations, Fundamentals of Differential Equations. It's not super important what edition you use. You can use the one with boundary value problems or the one that doesn't say with boundary value problems. Either way is fine. The boundary values problems one has a slightly different edition numbering than the without boundary values problems one. But if you want to use really kind of any reasonably recent edition, you could probably find a text that's an edition or 2 older than the most current one for quite a bit cheaper. Like particularly the one, there's an apple on the front of it. You'll probably find that one quite a bit cheaper than the more current versions. I think the current version, I think this is the current boundary value problems version, the 7th edition. And I think the equivalent with the similar cover non-boundary value problems, I think, is the 9th edition for the current version. So if you go 1 edition back or 2 editions back, it's going to effectively be the same material, but probably for a much cheaper price. So one note on this, as I think I kind of mentioned in the first announcement, is because we added this section so late, and because I just took over staffing the section late last week, we didn't have time to get the bookstore adoption kind of entered and everything squared away there. I did send the bookstore folks an email early yesterday to get that squared away. I haven't heard back from them. We have been having some trouble with the bookstore, so I'm not super confident that that's going to come through. But most of the time, you can get access to the materials much cheaper, not going through the bookstore. And a lot of students choose to do that. A lot of students also say that it's less of a hassle to just go through a third-party site than to go through the bookstore. So there are some different options for getting access to this book. You know, one that I mentioned already is you can buy a couple editions older from, you know, somewhere like maybe eBay or Amazon, you know, the marketplace on Amazon, something like that. We'll also take a look at Pearson's MyLab system. So, which used to be called My Math Lab. So if I call it My Math Lab, that's why. And you'll be able to get an access to an ebook edition of the book through there. Note that you will have a 2-week free trial for this system, whether you give them any money or not. So you'll be able to access the textbook today or even yesterday. And for an entire 2 weeks, you'll be able to access the book as kind of an ebook through that site. So there, you know, shouldn't be really access issues for these first couple weeks, and that should give you time to kind of, you know, get a hold of the textbook, especially with, you know, Amazon shipping these days being so fast. If you really needed an extra couple of weeks, you could, near the end of the couple of weeks, kind of make another account on Pearson and then kind of extend your couple of weeks out. But I wouldn't really recommend doing that 5 times. That seems like quite a bit of hassle. And especially if you're at this level, you're probably going to be, you know, using differential equations in your future courses. So you probably will actually want a physical text to kind of refer back to for future courses. Some other textbooks for these types of courses, for technical courses that are kind of problem-based like this, I think sometimes it's good to have a few different books to just hear different authors' perspectives on things. So another good one is this Polking, Bojas, and Arnold. This is the book that Pitt uses, University of Pittsburgh. It's a nice book. It's only in the 2nd edition, but I think it's been in the 2nd edition for like 20 or something years. So it might be hard to find a copy of this for a decent price. That's the only caveat with this one. You know, it hasn't been through like 10 editions where you can pick up edition 5 for dirt cheap. Edwards and Penny is another popular one that some of the folks at CCAC, I think, even use. This one has been through a lot of editions, so you can find one of these pretty cheap. And Boyce and DePrima is kind of, I would say, probably the standard at this level, at least one of the standards, but I know that some of our other faculty use this one as well. Boyce and DePrima, and this also has been through a lot of editions, so you can probably find an older edition for pretty cheap. You can also just, you know, scour the racks at half-price books or something and, you know, see what they have available. Kind of any introductory differential equations textbook is going to cover similar material, but again, each author has a little bit of a different style. They might have a slightly different approach to certain problems or a slightly different emphasis. Some of them emphasize the math side of things a little heavier. Some of them emphasize the applications and the physics side of things a little heavier. And that's one of the things I like about Nagel, the book for this course, is really each chapter is motivated by what is typically a physics problem that says, hey, we want to be able to solve this problem. Well, to be able to solve this problem, we ought to develop some mathematics to be able to tackle this problem. So, and then that development of that mathematics is what that chapter is about. So that's one of the things I really like about Nagel, is I feel like he ties it very directly into the physics and engineering applications. Another nice resource is Schaum's Outlines. I don't happen to have the DiffEq one with me in my home office. It's in my my on-campus office, but here's the calculus one. But Schaum's Outlines, the differential equations. The nice thing about Schaum's is they're very problem-oriented. So they just drill a whole lot of problems. You typically in a section, you'll have, you know, 5 or 10 problems where they do the problem statement, work through all of the details and get the answer. And then maybe 5 or 10 problems where they have the problem statement and the answer, and you have to fill in the details and reach the answer. So a lot of students find that really helpful for just the practical side of, just drilling some different problems. So I think I've mentioned all these down here. And then of course, any calc book is good to have as a reference, just in case you need to look up something, if you need to review an integration technique or something like that. A lot of calc books also have kind of a cursory treatment of differential equations. So as a kind of an overview, you could always take a glance through those chapters in a standard calc book. Stewart actually has first order and second order differential equations. Again, a pretty introductory treatment, but if you want an overview of the course, reading through those two chapters would be a pretty good place to start. Okay, so any questions so far? So on the topic of textbooks, the student registration instructions for the MyLab system, and I titled this just Book Access, Math 251. There's not going to be any homework or exams or anything like that assigned through this system. The only reason that I've put this up here is so you can get access to the textbook for these first couple weeks. Again, just with the timing of the course being added and staffed and all of that, it's a little hectic getting everything squared away. And so because the bookstore didn't have the book listed, and maybe still doesn't have the book listed, I haven't checked today, but like I said, the communications with the bookstore these days are a little challenging. This will get you access to the book. So you can log in here again with a 2-week free trial, so you don't have to pay them any money. If you want to pay them money, and if you just want to use the e-text for the book, you're certainly welcome to do that. If you want full access to the course to get the e-text, go for it. I will leave this open for the whole semester. But I mean, I like the physical text better, and if you were going to go that route, you might be able to find a PDF or something that you could buy and download, and then you could kind of have in perpetuity instead of losing access to whenever the semester is over. But here is the e-text version of the book. So it has all the same material as the standard book. Page by page, everything is the same. When I assign homework, I typically won't assign homework by problem number. I'll either write out the question, or it might be a problem that I came up with, or if I'm going to use a problem from the book, typically if it's a longer problem, I might screen cap it and put it in the homework. But just to make it a little easier for you to kind of to access things. And so we don't have, if you're using a slightly different edition, if the page numbers are different, or if the problem numbers are different, that way it's not, that way things don't get jumbled up. But you do have access to the, to the full textbook for the next 2 weeks, or for the 2-week free trial through this, this Pearson system here. And again, like if you get up to that 2 weeks, and if you're waiting for a book to come in and it hasn't shipped yet for some reason or something, you can kind of create another new account with a different email address and kind of re-up that 2-week free trial. It's a little bit of a hassle to do, but that is an option if you needed to extend it even a little further. And then during the summer, I don't have standard office hours. However, my schedule is quite flexible during the summer. So if you ever wanted to meet, shoot me an email. I'm happy to meet over Zoom by appointment, and answer any questions or discuss anything that you would want to discuss. So typically I'm pretty flexible, and we should be able to find a time that works for us both. Okay, any questions on anything? You can feel free to either post in chat or unmute yourself and ask that way. Okay. So let's go to the syllabus tab next. So there are 3 documents that were posted yesterday, and then I added a 4th one today on homework policies. This document's also in the homework assignments folder. So let's just start at the top. Sorry, my allergies are going crazy today. I've been working outside for the last few days, and with all the pollen and that. So the first page here is just kind of boilerplate. We have the required text for the course. Again, you can use the 8th edition, you can use the 9th edition, you can use the with boundary value problems or without boundary value problems. So pretty flexible there. If you really wanted to, you could even use a different differential equations book altogether. But you know, whenever I talk about this or that topic or something, it's going to be a little more confusing for you to kind of figure out what's going on. So I do really strongly recommend getting some edition of this book. I do recommend that you have access to a graphing calculator of some kind. You know, it could be a TI-83, it could be you know, a higher level like an Inspire or TI-89. But having some kind of access to a graphing calculator, you could also use for this course, you could use something like, you know, Desmos or something like that as your graphing calculator. That's not a problem. I know a lot of folks, especially in the summer, are kind of visiting students. Make sure that you check your CCAC academic email address, the one that's at acd.ccac.edu. Make sure you check it at least once a day, or at the very least, have it forwarded to an email address you check more regularly. Note that if you email me questions about anything sensitive, you know, grades or anything like that, I'll reply to your academic email address for security reasons. We have to respect educational records, so I'll reply to that. Now, if you choose to forward your academic email to a non-secure email to your personal Gmail or something, that's kind of on you. So if I email something confidential to your academic email and it gets forwarded to your Gmail and somebody sees it or something they didn't want to see it, that's kind of on you. So just be aware of that. The easiest thing to do is just, you know, add this email to your phone and just check it regularly. Also regularly checked Blackboard account. So you should be able to, you know, log into Blackboard. You should be regularly checking to see if any announcements or anything are posted. In the next day or so, we'll talk about the MATLAB/Octave programming language. MATLAB is a paid version of the language that you can, you know, download and use if you want. It's a little nicer, a little more feature rich than Octave. And you can buy a student version for, I think, 50 or $100 or something like that, commonly used in engineering and these kinds of fields, you know, applied math. If you want the freeware version, Octave is the freeware version. It's, you know, it's not a pirated thing or something. It's kind of its own program, but it's just meant to mimic the syntax of MATLAB. And, you know, it's really a completely fleshed out programming language with an IDE and all of that. So we'll talk a little bit about that in the next couple of days. And that's the language that we'll use for the labs. If you have experience with a different language, like say Python or something like that, you're welcome to use that. I'm not as familiar with those languages, so my ability to kind of help you might be a little less than, say, with MATLAB or Octave. But if you wanted to go that route, you're certainly welcome to. I have had students in the past, write their code in Python. You might also have to adapt the code that I give you in MATLAB or Octave syntax. You might have to adapt that over to Python. But if you want to go that route, go for it. The homeworks will be assigned and completed in like a so-called paper and pencil format. So we won't be using, MyMathLab or WebAssign or something to assign the homeworks and to submit the homeworks. The homeworks will feel more like a kind of traditional math class where, you get a set of problems, you write them up, physically with like paper and pencil, or if you wanted to type them up or something, you can do that, and then submit them. So you'll have to be able to scan or take photos of documents for submission. And we'll talk a little more about that in the homework policies document. And then just kind of the boilerplate, because it's an online course, ability to connect to and participate in Zoom sessions in case you have questions or want to meet about something, anything like that. Some more boilerplate. Carefully read through all of these documents, right? These are all the policies for the course. It's important. I'm hitting the high points here, but certainly not going through everything in great detail. let me just change up my meeting controls here a little bit. There we go. I just wanted to have chat up so that in case anybody has questions, you can stop me, you can ask in chat and I can answer. So most of the grade for the course is the homeworks. So the homeworks will be challenging. They will be, difficult problems that you'll have to take some time. You'll have to think through, work through, maybe work through once, not get it right, review the material, take another stab at it. Really, the homework is where a lot of the learning is going to be done. There is a final exam, more just because if I don't have a final exam in the course, people kind of block at that. So the final exam is worth 20% of the grade, homework 80%. The final exam will be in the similar format to the homework, where you'll download it, complete it, take photos or scans, and then upload it. So again, more information on that in a little bit. If you email me, allow me a business day to respond to you. Every once in a while, I'll get a student email and it might slip past me. Maybe I got a lot of administrative emails and I got bogged down or just didn't see it. So if it's been a day or so and you haven't heard back from me, send me a reminder to say, hey, I emailed you yesterday about this question. Have you gotten a chance to take a look at it? And just send me a reminder. Also, if you email me from an external address, those are much more likely to go to spam. So if you email me from your CCAC email, that's going to work a lot better. Okay. Again, read through all of these details. I'm hitting the high points here. Okay, so 4 and 5, I think, are the kind of last really important things from the syllabus. Well, let me just note this. Be very careful you don't get behind in the course. The material does tend to build on itself. If you get a little bit behind, especially in a 10-week course, this is condensed from 15 weeks down to 10 weeks. So, 1 week in this course is like a week and a half in a standard fall or spring course. If you get behind, it's very difficult to get caught back up. So make sure you don't get behind. Keep up with the work. Work a little bit each day, kind of chip away at the homework. Don't leave it until the last minute, and then try to get everything done, in a couple of hours. The course really is not going to work well if you take that approach. Homework has to be done on your own. So you can work in groups, you can go to a tutor, you can get help like that for general questions, but you shouldn't have somebody walking you through how to do problem 3 on homework 2 or something like that. And again, if you wait until the last minute to start the homeworks, you're going to be much more tempted to do something unethical than if you give yourself enough time. If you start the homeworks whenever they're posted and, start reviewing the material, work through them kind of slowly and diligently, ask questions of me whenever you come across them, you're gonna have a lot more success and a lot less temptation to do something unethical than if you leave things until the last minute and then you're kind of rushing to get the homework completed. And the final exam has to be taken during the week that it's scheduled. So, we'll talk about that in the all I can think of is course outline, and that's not in the course schedule. We'll talk about that in the course schedule, the exam week. And a little more boilerplate here at the end. So any questions on the syllabus? Okay, the course schedule is an outline of what we're going to be covering each week. So you can see for week 1, we have the first 3 sections in chapter 1. Week 2 will be first 3 sections in chapter 2, as well as lab 1, and so on throughout the course. For final exam week, the final exam will be available from 9 a.m. on July 24th through 11:59 on July 30th. And again, I'll post more information about that as we get closer to the exam. But the final exam is not meant to be super challenging. If you've done the work throughout the course, the final exam should be quite straightforward. But you can see that we're going to cover most of chapters 1 through 5. Chapter 6 is a little more theoretical, so we won't directly really cover a lot of that material. And then chapter 7 on Laplace transform will cover most of that chapter. And then touch on chapters 8 and 10, series solutions and PDEs. We won't be covering chapter 9 directly. Chapter 9 is on matrix methods for solving systems of equations using linear algebra to solve systems. We're going to focus on chapter 5, the differential operator method for solving systems. That way we don't have to understand the background of linear algebra, things like determinants and so on, and eigenvalues. But if you have had some background in linear algebra, and I'll mention this again when we get to chapter 5, if you have had some background in linear algebra, you might find chapter 9 interesting, and you might find chapter 9 to be even a better way to solve systems of equations than the methods in chapter 5. So if you have some background in linear algebra, some other doors are open to you, but that background is not assumed for the course. The only background that's assumed is Calc 2 and kind of the ability to do, having solid integration techniques, obviously differentiation, understanding power series, Taylor series, things like that. That's really the big, the main background for the course. Something that's, a little bit newer to CCAC is these kinds of documents. We're trying to get better about this. Really giving students more of a guide, especially for online and Zoom classes, these remote classes, to kind of how to approach a class like this, with it not having a, defined lecture component. Some students can kind of get caught up with kind of the planning side of things. So I put together this document for some pointers for what, maybe a typical week's workflow might look like. Really, the big idea here is, number one, don't use the homework to directly guide your study. Study the sections that are assigned. And then when you feel comfortable that you know the material, then approach the homework. And number two, don't wait until the last minute. Work a little bit each day throughout the week, and work an hour or two a day instead of trying to cram everything into 10 hours on Sunday. Also, the time expectations for the course. Note that this is a compressed course. It's 10 weeks instead of 15. This is a 3-credit course, but it's also a higher level course. It's not, an intro level course. It's a major course. So the kind of base time expectation is 8 to 15 hours per week. But you're probably going to be at the higher end of that for most students for most weeks. Again, just being that this is a, more challenging course, there's a lot of material that's covered. It is, fairly dependent material. So as the next chapter is typically dependent on the previous chapter and so on. So you're going to be kind of at the higher end of this scale for most weeks. And this might be what a typical week's, time allocation might look like. Again, this is very student dependent. It's very dependent on your familiarity with the material and with your comfort with the prerequisite material and so on. Any questions on that? Again, read carefully through, especially these 4 documents, just to make sure that you completely understand everything. It's even a good idea to take some notes of important points, maybe right in the front of your notebook. And then if you're in the middle of the course and you think, oh, what was the homework policy for turning stuff in late or something, you can just go right to the beginning of your notebook and you have kind of an overview there. And of course, these will be available electronically throughout the whole course. So you could always come back here as well. Okay, so lastly, in this area, homework policies. Homework is a very large percentage of the grade, 80%. So I'm going to adhere strictly to these homework policies. There are 3 headings here: the submission guidelines, the late policy, and the return policy. So submission guidelines for the standard homework sets, not for the labs, these should be submitted as a single PDF document. So the way that, most students kind of prefer to do these kind of submissions or do the homework is they prefer to physically write things out on paper with, pen or pencil, and that's perfectly okay. You should be able to take either photos, a lot of students use their phones, take photos, or, use a printer, scanner, copier kind of thing and scan that material in and create a single PDF document. This isn't super hard to do these days. So I note down here that one way to do it is kind of dump everything into a Word document. If you have pictures or something like that, maybe you have to screen cap and then move it over to the Word document or something like that. If you have a Mac, it's actually really easy to create PDFs. Windows are a little harder, but you can definitely still do it. But from Word, you can always export a PDF. Or if you're using your phone, there are a lot of phone apps that will do something like this. On my iPhone, the Notes app does a great job. You just open Notes, you make a new note, you do the click on the scan documents tool, and then you just kind of like put the paper in view, and it'll figure out where the boundaries of the paper are and take the picture for you. And then you just kind of flip through the pages, and it'll just kind of keep scanning them for you, and then crank out a PDF for you. You can email it to yourself, kind of make sure that everything's the way you want, and then do the submission. So again, please submit as a single PDF document, and please include your name as part of the document. So something like, your last name, homework 1, or something like that. .pdf would be a good name. Just that way, whenever typically what I'll do from Blackboard, I'll download them onto my computer just to make it easier for me to kind of go through them and grade them. And that just keeps straight whose work is whose and in what file and so on. Note that the work must be legible. Any illegible work will not be graded. So if I can't read it, I'm going to assume that it's wrong. A couple of examples. I don't mean to, pick on anybody with this or anything, but just to give examples of some previous work. So from a recent semester, this is an excellent example. This student, basically every one of their homework submissions looked like this. You can see that it's legible. It's obviously handwritten, but it's legible. The photo is of good enough quality for me to read. If one of your photos is really blurry or something, review the PDF, make sure that it's readable. If it's really blurry, you can redo it. It should only take a couple of minutes to get these scans and get the PDF created and everything and get it looking nice. Some examples that aren't so great, something like this, like I can kind of tell what's going on. Sum n equals 0 to infinity. It looks like a sub 0, t to the n, so the 0 isn't right. But you can tell that, the further down that I get, kind of the worse that it gets. And, by the third or fourth line, we're to the point where even if I had the solutions right next to me, I can't even really tell if it's correct or not. So again, I don't mean to, I'm not using anybody's names here. I don't mean to pick on anybody, but just to give an example of, illegible work. Here's an example of work where I can read each of the characters. And I mean, these were both final submissions of work. I can read all the characters, but I don't know what's going on. Right. This is from the Laplace transform section, but I can tell that up here, but it's like, okay, here's just a random expression. Here's another random expression. Here's some stuff that's scratched out. Like I can't really, I can read each of the characters, but there's no logical flow to it. So make sure it's legible, make sure that there's a logical flow. This is usually going to mean that you're not going to want to submit your first attempt as your final copy. So you might, You might do some scratch work over here and then recopy it kind of in good form so that it's legible, so that it's readable, and I can understand the logical flow. That's going to get you a lot more points than if I can't understand, what's going on, or if there's a lot of stuff scratched out or whatever. Now, I think I did mention it here somewhere, like, I don't expect you, if you make one little error or something that, oh, you have to scrap that page and rewrite the whole page. No, I mean, if you need to scratch something out and correct something, that's okay. Yeah, here. It's okay if you have, a couple of corrections, but it should be easy to read, right? It shouldn't be like full of corrections. It shouldn't be a first draft or a scratch paper. So the late policy is detailed here. Basically 20 percentage points deducted for each day late, and no assignments accepted after day 4. So these are calendar days, not business days. And the first assignment I actually, well, assignment 0, which we'll see in a minute here, I actually made due just before midnight this coming Friday. But then starting with assignment 1, I haven't decided exactly what days I'll try to shoot for. So it might be kind of a different day each week. The things will be due. I typically want to give you about a week for each homework assignment so that you have time to kind of look over it and kind of carefully go through the problems, take your time with the problems, and then and have plenty of time to kind of get the submission finalized and all of that. And then the return policy, so getting the graded homeworks back to you. I'll make sure to get everything returned to you on or before midnight on quote day 4. And then I'll post the solutions. And this is the reason that no submissions will be accepted after day 4, is that I need time to review it and then get the solutions posted so that your fellow students in the class can review the solutions, review their work, get an idea of some of the feedback before the next assignment is due. So that way, if any mistakes were made on a given assignment, they can be corrected before the next assignment. Okay, let me jump back to this share. Any questions so far? You guys are a quiet bunch. I just did one of these for Calc 3 just from 10 to 11, and they had, I don't know, 20 or 30 questions or something in chat. So
I have a quick question.
Yeah, sure.
Just in terms of you were talking about how much time we allot on a weekly basis. What can we expect in terms of like the lab weeks? Would that be like an extravagant like increase in time allotted, or would it be roughly the same as any other week?
Yeah, so my goal would be for it to be roughly the same. That's, the kind of lab is taken into account in the lab is basically part of the homework for that week. So it shouldn't be, a huge increase in effort or in time dedication or anything like that. Now, of course, things vary for different students. Different students struggle with different things. So if a student, really struggles with the labs, that might be a busier week for them than a week that they feel a little more comfortable with. And some other student might, really struggle with the material in chapter 2. And so that might be a busier week for them, and the lab week might be an easier week. So there is a little bit of that. So I mean, it is somewhat student dependent. Obviously a student who has experience in computer programming or even experience with MATLAB, the labs are going to go a lot faster for them than a student who doesn't have that experience. Just the same way that a student who, has taken, some calc-based physics courses, some of the physics problems will go a lot quicker for them than the student who doesn't have that experience. So it is somewhat student dependent, but my intention is for, the labs to be kind of basically part of the working through the homework problems kind of sections here. So the lab shouldn't be kind of in addition to the homework. It should be, it's kind of like part of the homework.
Yeah, that makes sense.
Okay, yeah. Yeah, good question though. Any other questions? And there are only 4 labs. And as an aside, for the labs, basically, I've done most of the programming for you, and I'll kind of, send you a zip file, or we'll post the zip file, and you'll download it. Most of the programs will be completed, and you might have to fill in a couple lines or tweak a couple of things or change some initial conditions and see what happens. So it's going to be more about using the programs than kind of creating the programs from scratch, or understanding proper programming techniques, that kind of thing. So it's really going to be more about using the programs and having a kind of a general idea of what's going on, rather than, I'm certainly not expecting you to be an expert programmer or something like that. Any other questions? Okay, so then jumping over here to homework assignments, again, the same homework policies document is copied here. And you'll see homework assignment 0 is posted with the with its folder, due 5/26. It's due this Friday at midnight. And if you navigate in here, you see there's the homework assignment 0, and the submission tool. So the submission tool, you can go into here when after you've created your PDF, you have it saved on your desktop or something, you can then come in here, do your browse local files, grab that PDF, and then submit. And your homework 0, these homeworks will be posted as PDFs. And the goal of homework 0 is just to practice the submission system. So, get the app on your phone working if you need to, or get the scanner working the way that you want, or however it is that you want to do this. That's really the goal of homework 0. It's due this Friday by midnight. Again, kind of a shorter time frame, but these are not challenging problems. This is review material. Really, the goal is to get the technological aspects, to get the administrative aspects all kind of hammered out. So that's why the short time frame for this. I certainly would not only give you 3 or 4 days for a legitimate homework assignment. It's worth 10 points. So the typical homework assignment will be worth a lot more, typically 70 to 120 points. But, again, for just this kind of intro assignment, just getting all of the technology sorted out, lesser points for this one. And as I put up here, really the goal of this is to make sure that the submission systems are working. So you should submit at least 2 pages, preferably 3 or 4 pages, just to kind of make sure that you're able to stitch together the PDFs properly, that kind of thing, So try to handle all of the complexity in this assignment that's lower stakes, that's easier material and so on, so that for the more difficult material, you aren't wrestling with it there. So you can see, problem 1, compute the second derivative of this function, making sure to use, say, product rule and chain rule and so on. Problem 2, compute this integral using partial fractions. So this is material that will be important for the course. We'll see partial fractions come up, quite a bit. So this is important material for the course. So it's kind of dusting off the cobwebs, but also, these problems just are a little lengthier in terms of writing stuff out. So that way, there's enough material there that you can see whether the PDF tools are working properly. And then showing Euler's identity, e to the I theta equals cos theta plus I sine theta. Again, an important idea that we'll use in chapter 2. I is the imaginary number. You don't need to know much at all about complex numbers or, calculus with complex numbers or anything, just that I squared equals -1 and I to the 4th equals +1. And just use these Maclaurin series to kind of show that the left-hand side equals the right-hand side. And again, assuming that all of the complex number stuff works out just fine, which it does. So things like putting complex numbers in infinite series doesn't break them or something like that. that works fine. And that is true. So again, work through this, write it up in whatever form you plan to write up the rest of the homework for the course. Create the PDF in whatever way you plan to create it for the rest of the course. You might have to do a little bit of research to figure out, what app you like better, or what method you like better. You might try it a couple of different ways, see what works for you or your computer, the technology you have available. But work through this, turn in your submission, and then and if you have questions, if you're not sure if it came through okay, or if you just want to check in and say, hey, I submitted it, does everything look good, shoot me an email. I can pop on before the due date and check it for you. And for this, this due date isn't super hard and fast. If you submit it, you think everything went well, and come Saturday I take a look at it and it's like, oh, something messed up, you can resubmit it. The goal of this is really to make sure that we get all of the technology working. Now, future homeworks, you get one submission, right? You submit it once, and you have to have you'll want to have the homework problems correct and in good form and so on in that submission. But for this one, this is really the goal, is to get everything up and running. Okay, so are there any questions on anything that we talked about, or any questions on something that I skipped over, didn't talk about, or any of that? Okay, I will stop the recording and